Here I have a little 555 timer delay circuit. It's got a relay on the board as well, and it's driven by a power bank. And I have over here a 12 volt motor which should come on for a set period of time determined by the variable resistor on the delay circuit. So if I press my button, oh, nothing happens. I've got to turn the power bank on. I put switches on power banks, don't know why, I just feel they ought to have them. And then if I press my switch, then my motor turns for a set period of time depending upon the position of the variable resistor. Oh, I do like it. I love things like this. Very sad, but there we are. Love it. Right, so we'll turn that off. So that's brilliant. What's wrong with it? Well, the thing that's wrong with it is I want to be able to use smaller motors and to use lithium cells. Lithium cell might go down as low as 3 volts before. I've put a protection circuit on it. Oops, can we see that? Yeah, I put a protection board on here so that it won't go down below whatever the protection board goes to, probably 2.8 or something like that. And when I charge it, it won't go above 4.2 volts. It's something I've pulled out of somewhere. Originally, the first time I pulled it out, it had about 99 milliamp hours, but I charged it and tried it again and I got 305 milliamp hours. Not brilliant. Most people wouldn't want a cell that size, but if I'm running a 300 milliamp motor, then it's going to run for about an hour on this, which is long enough for what I want. Problem is, after spending years developing gearboxes of my own design, I found these on the internet. Just over £1 from China. Makes all my messing around with gears, although I enjoyed it. It's fun. Getting these to work was quite fun, but when you can buy one for £1, hardly worth it. So I tend to use these nowadays. Nice motors, seem to work well. I've cut the top and bottom off where there was a strap around so that I can have it flat. I haven't had any fallout yet. They seem to be quite tightly in, so they seem to work well. So what's wrong with my 555 timer circuit? Well, a normal 555 needs 5 volts, and that ain't good for 3 volts. So what I need to do then is to design a circuit for 3 volts. For that, I've used a CMOS 555 and a 3 volt relay. To circuit diagram, pin 5 then connects down to ground through a small capacitor. Pins 6 and 7 connect together. They then connect to a variable resistor up here. That then comes in, and then it comes down through a capacitor, 100 microfarad in my case, down to 0 volts. It's a sort of pseudo 3 volts they have here, so I have 3 volts coming in there and 0 volts in here. I have a switch so that when I press it, it switches on the 555 timer, but of course as soon as I release it, the 555 hasn't any current, so it goes off. So I need some way of holding it on. So I need another switch in parallel with that one, and that's going to be controlled by a relay. And the relay, of course, has got to come from the pseudo 5 volts, not the input 5 volts. So I'd have problems if I did it from that. So I just bring it across here and down there. That's bad, isn't it? Never mind, it's not connected there. It's I should have brought it down that way. That would be better, wouldn't it? Make it clearer. So it's not that bit. It's coming down here and it's controlled there. Down here, to control it, I need a transistor. The problem being that with a 5.5 that's CMOS, it can't drive the relay directly. So that's more or less the circuit. Oh, just one more thing across the relay. I do need a diode so that any back EMF don't kill my transistor. So that's my start switch, that's my relay switch, that's my relay coil with a diode across it, transistor down here, driven by a resistor from pin 3 of my 555. Oh, I need pin 2 to do something. So what I do is to connect that down to ground so that when it gets power to it, I need a resistor as well to pull it up, a pull-up resistor to positive. So at first, when we charge it, this acts like a short circuit, holds pin 2 low. After a very short period of time, that charges up, this resistor pulls pin 2 high, and that triggers the 555. The output then comes high, depending upon the time of this variable resistor here, and its capacitor down here, which is 100 microfarads. Right, so that's the circuit. Now I need to build it. What am I going to build it on? Well, I could design a printed circuit board, but is it a worthwhile activity for this particular one-off job? So no, I've got a piece of what I call strip board, commercial name Veriboard, I think it used to be. It has copper strips going all the way across the rows. And then I can put my components down the columns. It's a bit of second-hand board that I've cleaned up. It's easy enough to clean up, and that's one of the things about it. If it were a printed circuit board, it couldn't. Where I don't want the strip to go all the way across, like underneath the chip, I've got to put breaks in. To do that, I can use a drill bit or a special tool for doing it with, but a drill bit works just as well. Right, so now I need to design my circuit. So if I have a look at my circuit, what I have is the circuit board underneath, well, the Veriboard underneath. You can see where the holes are. The strips are going along this way. I've numbered the columns from 1 to 20 and the rows from 1 to 9. I then have worked out where I need to put the cuts in it, which I've then done on the board. So now I need to put some links in. For example, here I've got a link from row 9 to row 1. So if I put that in, so it goes from row 9 down to row 1, and it's on column 19. So that's that one. I then have a couple of links over here on column 9, the top 2 rows, and then the next 2 rows are joined together. So 2, 4, 6, 8, 9. So that link, come on, there, goes into there. I need another link, the 2 rows below, that's where pins 6 and 7 are going to be joined together. And I need some power links. So over here I'm linking column 8, column 4, column column 3, 1 row down, column 3, 1 down to 1 up, so I can put that in there. Then I need a positive wire which goes from in column 4 from the top, goes down to there. So now I've got my board. That's sort of equivalent to a printed circuit board. It's probably, I don't think, much difference between making a circuit board and this, apart from if I make a circuit board I can make a mistake. With this then I can make a mistake but unsolder it and use different holes. That's my links in. I can now start putting resistors in, I suppose. On column 14 I need a resistor down to my LED, so that means it's 1, 2, 3, 4, 5 holes, and it goes from the top 1, 2, 3, 4, 5, sort of there, is it? There, down to there, and that's in the wrong place because I need 1, 2, 3, 4, it's the 5th one across, 1, 2, 3, 4, 5, so I've got it in the wrong place, so I can put it into there, and that's put it in the right place. Now I need to put in my LEDs and some other bits and pieces and then solder that up. So let's let's turn it over. We can see it. Take my trusty iron. Find some solder first, it would be useful. Trusty iron, very dirty iron of course. Put that on, put the point on, pull a bit of solder out, count to 10, and I don't know if we can see that or not, a bit of solder on, and there. Don't think that's too bad a joint, so I can do all the rest of those then now. So we'll hang on a minute. So now I've got my circuit board, I've put in my link down the side, I've also put in my connector here for my motor to connect onto. I've put my 3-volt relay in, I've put my resistor in for my LED, got my 2 links in here, got my connector here for my power to come in, 2 links for power here, resistors here and a capacitor for the pin 2, and then a connector for the switch. I now need to put on my chip, so if I can find my chip, there's my chip. It's going to go, put a dot on the chip so I know which is pin 1, and that then goes, well, it won't go because its legs are splayed out, they always seem to come like this, so just put it on its side, bend it over, and now the legs seem to be parallel. Make sure I get it the right way round. And will it go in now? Have I bent it enough? Not quite. I ought to bend it again, but never mind. So that's my chip in. I need to put my transistor in. I've got to be careful with my transistor though, because my transistor is what a colleague used to say, flies backwards in this particular case. So the curve of the transistor is going towards the power socket, so I need to make sure that when I put my transistor in, not only do I make sure I get it in the negative rail, but that it's across the hole, so the base and the collector of the transistor aren't connected together. What else do I need? I need my variable resistor, which goes in something like, it goes on the top row in there. So that's my variable resistor in. Variable resistor. I'm going to need my capacitor, which has got to be 100 microfarads, and a few other bits and pieces. What I could do, of course, before I do that, I could check that the LED lights, but, well, I've got them bits in now, so I'll solder them up now. Right, so here I've got my completed board. I've put my diode underneath, because it's a lot easier, underneath the relay. So now what I should be able to do is to test it to see if it'll work. To do that then, I've got one of my little models. Don't know if we can see this or not. It's a little man and a mouth, so I can't really see that. So what I'll do is just move away a bit and hope. There we are, there's the little man and the mouth. So what I'm going to do is to connect the motor up to the circuit, connect my, making sure of course I get it the right way around, because I haven't put a protection diode on. Put my cell onto it and nothing happens. So what I need to do is to put a switch on. Need a switch. I ain't got a switch handy, so I'll just pop a knife across to short those two together. Can I do that? Oh. And there it works for a short period of time. If I wasn't happy with the time, I could of course alter the capacitor. I'll short the two together again. And it stops again. Oh, I do like that. I think that's nice. I'm right happy, chuffed that it works. Of course the 555 and relay circuit is far more complicated than it needs to be. But I've enjoyed building it and it works, so it'll do. It'll do, yeah. Oh dear, I must have another go. Oh, I could play with that all night. Anyway, bye now. Goodbye.